Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Hello everybody. I am PS Chatterjee with you. Today it is commentary on IS-456-2000. Clause number 6, concrete. This is part number 12. Structural design only. A channel with different vision. If you are watching my video first time, for more information, you may start from part 1. I hope you are going to enjoy this video. Before start of the lecture, please like, share, and subscribe my channel. Clause 6.1, IS-456-2000, concrete. Definition of grade of concrete. The grade of concrete refers to the strength of concrete mixtures by its compressive strength at 28 days. It is denoted by the letter M followed by a number, such as M20, M25, M30, etc. The M stands for mix, and the number denotes the specified compressive strength of the concrete in megapascals, MPa. For example, M20 concrete has a compressive strength of 20 MPa, M25 has 25 MPa, and so on. The higher the grade number, the stronger the concrete mix. Clause 6.1, grades. The concrete shall be in grades designated as per Table 2. Table 2, grades of concrete, Clause 6.1, 9.2.2, 15.1.1, and 36.1. Column 1, Group. Column 2, Grade designation. Column 3, Specified characteristic compressive strength of 150 mm³ at 28 days in Newton per square millimeter. M10, M15, and M20 grade of concrete belongs to the ordinary concrete group. 1. Concrete with grade designation, M10, compressive strength, 10 Newton per square millimeter. 2. Concrete with grade designation, M15, compressive strength, 15 Newton per square millimeter. 3. Concrete with grade designation, M20, compressive strength, 20 Newton per square millimeter. Continuation of Clause 6, IS-456-2000, concrete and Table 2. Concrete with grade designation, M25, M30 and M35 belongs to the standard concrete group. Grade designation M25, characteristic compressive strength 25 Newton per square millimeter. Grade designation M30, characteristic compressive strength 30 Newton per square millimeter. Grade designation M35, characteristic compressive strength 35 Newton per square millimeter. Concrete with grade designation, M40, M45 and M50 belongs to the high-strength concrete group. Grade designation M40, characteristic compressive strength 40 Newton per square millimeter. Grade designation M45, characteristic compressive strength 45 Newton per square millimeter. Grade designation M50, characteristic compressive strength 50 Newton per square millimeter. Notes. Note 1. In the designation of concrete mix, M refers to the mix and the number to the specified compressive strength of 150 mm size cube at 28 days, expressed in Newton per square millimeter. Note 2. For concrete of compressive strength greater than M55, design parameters given in the stand may not be applicable, and the values may be obtained from specialized literatures and experimental results. Clause 6.1, IS-456-2000, Concrete. Clause 6.1.1 The characteristic strength is defined as the strength of material below which not more than 5% of the test results are expected to fall. Clause 6.1.2 The minimum grade of concrete for plain and reinforced concrete shall be as per Table 5, M10. Clause 6.1.3 Concrete of grades lower than those given in Table 5 may be used for plain concrete constructions, lean concrete, simple foundations, foundation for masonry walls and other simple or temporary reinforced concrete construction. Clause 6.2, IS-456-2000, Properties of concrete. Clause 6.2.1, Increase of strength with age. There is normally a gain of strength beyond 28 days. The quantum of increase depends upon the grade and type of cement, curing and environmental conditions, etc. The design should be based on 28 days characteristic strength of concrete unless there is evidence to justify a higher strength for a particular structure due to age. Clause 6.2, IS-456-2000, Properties of concrete. Clause 6.2.1.1. For concrete of grade M30 and above, the rate of increase of compressive strength with age shall be based on actual investigations. Clause 6.2.1.2. Where members are subjected to lower direct load during construction, they should be checked for stresses resulting from combination of direct load and bending during construction. Clause 6.2.2. Tensile strength of concrete. The flexed Ural and splitting tensile strengths shall be obtained as described in IS-516 and IS-5816 respectively. When the designer wishes to use an estimate of the tensile strength from the compressive strength, the following formula may be used: flex Ural strength, FCR equals 0.7 into square root of FCK, Newton per square millimeter. Where FCK is the characteristic cube compressive strength of concrete in Newton per square millimeter. Clause 6.2.3. Elastic deformation. The modulus of elasticity is primarily influenced by the elastic properties of the aggregate and to a lesser extent by the conditions of curing and age of the concrete, the mix proportions and the type of cement. The modulus of elasticity is normally related to the compressive strength of concrete. Clause 6.2.3.1. The modulus of elasticity of concrete can be assumed as follows: EC equals 5000 into square root of FCK. Where EC is the short-term static modulus of elasticity in Newton per square millimeter. Actual measured values may differ by plus/minus 20% from the values obtained from the above expression. Continuation of Clause 6.2, IS-456-2000, Properties of concrete. Clause 6.2.4. Shrinkage. The total shrinkage of concrete depends upon the constituents of concrete, size of the member and environmental conditions. For a given humidity and temperature, the total shrinkage of concrete is most influenced by the total amount of water present in the concrete at the time of mixing and to a lesser extent, by the cement content. Clause 6.2.4.1. In the absence of test data, the approximate value of the total shrinkage strain for design may be taken as 0.0003. For more information, see IS-1343. Clause 6.2.5. Creep of concrete. Creep of concrete depends, in addition to the factors listed in 6.2.4, on the stress in the concrete, age at loading and the duration of loading. As long as the stress in concrete does not exceed 1/3 of its characteristic compressive strength, creep may be assumed to be proportional to the stress. Clause 6.2.5.1. In the absence of experimental data and detailed information on the effect of the variables, the ultimate creep strain may be estimated from the following values of creep coefficient. That is, ultimate creep strain / elastic strain at the age of loading. For long span structure, it is advisable to determine actual creep strain, likely to take place. Age at loading 7 days, creep coefficient 2.2. Age at loading 28 days, creep coefficient 1.6. Age at loading 365 days, creep coefficient 1.1. Note: the ultimate creep strain, estimated as described above, does not include the elastic strain. Now the question is, what is elastic strain? Elastic strain refers to the deformation or stretching of a material under stress that is reversible once the stress is removed. Continuation of Clause 6.2, IS-456-2000, Properties of Concrete. Clause 6.2.6. Thermal expansion. The coefficient of thermal expansion depends on nature of cement, the aggregate, the cement content, the relative humidity and the size of sections. The value of coefficient of thermal expansion for concrete with different aggregates may be taken as below. Column number 1, it is type of aggregate. Column number 2, it is coefficient of thermal expansion for concrete per degree centigrade. 1. Quartzite, 1.2 to 1.3 into 10 to the power 5 per degree centigrade. 2. Sandstone, 0.9 to 1.2 into 10 to the power 5 per degree centigrade. 3. Granite, 0.7 to 0.95 into 10 to the power 5 per degree centigrade. 4. Basalt, 0.8 to 0.95 into 10 to the power 5 per degree centigrade. 5. Limestone, 0.6 to 0.9 into 10 to the power 5 per degree centigrade. Note: coefficient of thermal expansion is defined as the ratio of the change in dimension of the material to the original dimension for a 1 degree Celsius change in temperature. It is typically expressed in units of per degree Celsius. End of commentary on IS-456-2000, Part 12. Next video will be on Clause 7, Workability of concrete. I hope you enjoyed this video. Please don't forget to subscribe my channel. Thanks for watching this video.